Hi guys, so I'm going to be talking about implicit differentiation, which is 2.5. Okay, so I'm going to start off with defining some vocab words. So explicit form. Explicit form is when the equation or expression is written in terms of one variable. One variable. So we see that a lot, like y equals 2x, y equals x squared, all that stuff. Those are explicit form because they are written in terms of one variable, x. Now, implicit form, kind of the start of this lesson, I guess, implicit differentiation. It's written in terms of more than one variable. Okay, so what could that look like? That could look like x times y equals 5. And so this one you can actually rewrite it to be explicit form. So it's easier to differentiate. You can rewrite that as y equals 5 over x. Alright, and then you can just differentiate like normal. I'm going to rewrite it like this, so you can use a power rule. Okay. So that means it equals negative 5 over x squared, like that. Okay, but sometimes it can't be rewritten. So for example, something like this, x squared plus 5y to the 6th equals 14. So this cannot be rewritten. I guess you could if you really tried, but that would be really hard. But it can't be rewritten, so we're going to use implicit differentiation. So I have some examples right here. So this one, how we would go about doing this is just the power rule, like usual. You differentiate with respect to x, and this is x, so everything is good. So 6 times the power up here, and then x, 6 minus 1, 36, x to the 5th. Okay, so when it's with a y, then things are a little bit different because the variables do not agree, and here is where we have to use the chain rule. Okay, so how will we use the chain rule? Well, the chain rule looks like that, right? And then the derivative, it looks like this. So how we make 6y to the 6th fit this kind of format? You can set, so f of x would be 6x to the 6th, and g of x would be y. And so how you would do that is, then it would just be, oh, I got that wrong, 36y to the 5th times dy dx. So dy dx part is the chain rule. So this would be equal to, looks pretty similar to this one, right? You just change the variable, but you need to multiply by dy dx. Okay, so that is how the chain rule works. And so have some more complicated, some examples that I want to do. Okay, so I forgot to write the instructions, but that's okay. It's just, find the derivative, dy dx. Okay, so take the derivative of both sides, and of course 0 is still 0 because it's a constant. So we can start with this x squared. X squared, the derivative is 2x, and there's nothing to multiply with the chain rule because the variables agree. You can multiply by 1 if you really wanted to, but why would you do that? 2y, this one the variables don't agree, so dy dx, minus 4. I just realized I wrote that wrong. This is a y. My bad. So this is 4 plus 6 dy dx. And then this 9 right here, that's a 0 because the derivative of constant is 0. So it will look something like this. I'm going to do some combining and factoring and all that stuff in pretty much one step. So I'm going to factor out the dy dx from these two terms. Alright, so that will be 2y plus 6. And I'm going to move the remaining terms over to the other side. So it'll be 4 minus 2x. And so we can find dy dx by dividing by 2y plus 6. 2y plus 6. That's it. That is the derivative. So, okay, this one is a bit harder. Find the points at which the graph of the equation has a vertical or horizontal tangent line. So the graph of the equation has a vertical / horizontal tangent line when the derivative is either undefined or equal to 0. So obviously then we have to find the derivative first. So we're going to find the derivative. That'll be 50x, right? 25 times 2, and then it's just an x now. 16 times 2, 32y, and then the variables don't agree, right? The chain rule. Okay, so multiply by dy dx, and then plus 200 minus 160, variables don't agree, dy dx. Okay, and then this one is just a constant, and that is 0, so we just ignore that. Okay, and now I'm kind of running out of space. Let's continue over here. Let's jot down that last step real quick. Okay, so that is where we left off. Alright, so right now I'm gonna do the same thing I did before, right? Isolate dy dx by factoring it out of those terms first, the 32y and the 160, and move everything else to the other side. Negative 50x minus 200. And so your dy dx is what? Okay, over 32y minus 160. And you can actually simplify this, so I'm going to do that. Y minus 80. Okay, so that is the dy dx, but that isn't the answer because it's asking for the points at which the graph of the equation has a vertical or horizontal tangent line. So to find that, I'm going to set the derivative equal to 0. That basically just means the numerator, right? So set the numerator equal to 0 and set the denominator equal to 0 too, because the equation can have a vertical tangent line when the derivative is undefined. So it's undefined when the denominator is 0. So I'm going to just do that first. 16y equals 80, y equals 5. Okay, and right here, negative 25x equals 100, so x equals negative 4. Okay, and so to find the points, we would plug this into the original equation. This original equation right here. So I'm gonna start with the x values first because it comes first in the alphabet. Okay, so I'm just plugging this in. Right. So these were originally x's, and I just plugged them in. Plug the -4 in for the x. Okay, what is this? This is 400 plus 16y squared minus 800 minus 160y plus 400. That's kind of an ugly 4. 400 equals 0. Okay, so the constants right here, that adds up to 0, so we're just left with 16y squared minus 160y equals 0. And of course, you can just factor out like that, y equals 0 and 10. So that means the points here are -4, 0, and -4, 10. Okay, so we have one set of points, and this is the horizontal tangent, because that is where the derivative is equal to 0. Okay, now, same equation, but now I'm going to plug the y in and solve for x. 160 times 5 plus 400 equals 0. Alright, what is that equal to? 25x squared plus 400 plus 200x minus 800 plus 400. And again, yay, the constants will cancel each other out, that adds up to 0. And just cross them out like that then. 25x squared plus 200x, I'm just going to simplify that real quick. That would be x squared plus 8x equals 0. X will be 0 and 8. And so we have our other set of points, which is, what was the, okay, 0, 5. Right, the y value we found was 5. 0, 5, and 8. Oh! This is -8. Sorry. -8. 5. Okay, this is the vertical tangent, and I ran out of space, so I'm going to put this to the back. Or I'll just put this aside. Alright, and then the other, there's problem 3. Other questions I wanted to do. 2 sine x cosine y equals 1. This one is a bit harder. It has trig. Yay, everyone loves trig. Alright, take the derivative of both sides. That's an ugly bracket. That's okay. Alright, so I'm just gonna factor that 2 out, and then also do the product rule, because it's sine x times cosine y. So we're gonna use the product rule. I guess I'll write it over here. We'll say it's AB derivative of A times B plus A times derivative of B. Like that. Okay. So following this, let's do the derivative of sine x, which is cosine x times cosine y. Okay, and then plus a times b prime. Sine x, negative sine y, dy dx. Remember, chain rule, because the variables do not agree. And then this is just 0, because 1 is a constant, and the derivative of a constant is 0. Alright, so you can just kind of divide that by 2. The 2 doesn't really matter anymore. And we're left with, what are we left with? And I'll move the cosine x, cosine y to the other side. Negative cosine x, cosine y. Dy dx equals cosine x, cosine y over sine x, sine y, which also equals cotangent x, cotangent y. You generally don't want to have trig functions in the denominator. So I'm just gonna rewrite it like that. Cotangent x, cotangent y. Okay. Last problem. I think this one's the hardest. So hardest for last. It's another trig problem. Find dy dx for cosine y equals x. Find the largest interval of the form 0 is less than y is less than a such that y is a differentiable, that's a long word, function of x, and then write dy dx as a function of x. Okay, so we're going to start off by the first part, find dy dx for cosine y is equal to x. So the equation is cosine y is equal to x, and then the derivative, we're going to take the derivative of both sides with respect to x. Oops. Got a little ahead of myself, because this is equal to 1. Okay. Cosine y, the derivative of that with respect to x, that would be negative sine y dy dx, and so we can conclude that dy dx is equal to negative 1 over sine y. You can also rewrite it as negative cosecant y. That's okay. Okay, so y is going to be a differentiable function of x when it's not undefined. So to find where it is undefined, you would set the denominator equal to 0. And so this is what y can't be. Y, so I guess I should write it like this. Okay. Sine y cannot equal 0. And so where does sine y equal 0? Sine y equals 0 every pi n. So sine y will equal 0 every pi n. And it has to be of the form 0 is less than y is less than a, right? So that's a hint. One of them is 0. Right, pi, like that. So this is the largest interval where the y is a differentiable function of x. Because if I wrote 2 pi, that would include pi, and it's not differentiable at pi. So this is the largest interval where that will work. I'm gonna box this because this is one of the answers. This question has a lot of parts, so that's one of the parts. This is another one of the parts. This is dy dx, and then we found the largest interval. Okay, now we're gonna write dy dx as a function of x, because right now it has a y over there, right? So we negative 1 over sine y. Okay, so how would we rewrite this as a function of x? So what we can do is you can use okay, I'm gonna get a different color pen for this. You can use the Pythagorean identity, where it says, the colors don't look very different, but okay, that's okay. Sine squared y plus cosine squared y equals 1. And so we want to find sine y, right? And so we could rewrite that as sine y equals square root of 1 over cosine squared y. And that's still a y, and we don't want that. But you can look back to the original function, and the original function says that cosine y is equal to x. So that means we can replace this part with x squared, because that is cosine y squared, or cosine y squared. like this. So sine y is equal to 1 minus x squared. And then that is where, I'm going to switch back to blue, that is where we can rewrite it as dy dx is negative 1 over 1, or square root of 1 minus x squared. Also write restricted domain because the has to be a differentiable function. This one, it cannot be, the denominator cannot be 0. So these are kind of the answers to all of the parts of the question. Dy dx for cosine y equals x is negative 1 over sine y. The largest interval is 0 is less than y is less than pi. And then where is it? The derivative as a function of x is dy dx is equal to negative 1 over the square root of negative 1 over the square root of 1 minus x squared. Okay, that is all I have. Thanks for listening. Bye-bye.